All right, before we go to that next problem that we took a peek at in that last video, I looked back at this one and I thought I'd pose a problem and say, what if it wasn't just an x in there, but what if it was the sine squared of 2x minus 1 equals 0? Well, it's not a big deal for us because we can still do the same steps. We can add 1. We can take our square root, give us the sine of 2x equals plus or minus 1. Now we ask, because we have the sign isolated, we can say, where does the sine of 2x equals 1? Where does the sine of 2x equal negative 1? So where does the sine of 2x equal, where does the sine of equal 1? Well, it's still at pi over 2, but instead of x equaling pi over 2, we would say 2x equals pi over 2. That's where the sine is equal to 1. So when 2x is pi over 2, the sine of pi over 2 is 1, and we just divide that then by 2, and we get pi over 4. And over here we'd say, okay, where is the sine equal to negative 1? Well, it's equal to negative 1 at 3 pi over 2, but it's not x equals 3 pi over 2, it's now 2x, and then divide by 2. So it's really not a big deal. And we should understand that when we put that 2 in there, we're changing the period of the function, aren't we? We are taking it and we are horizontally compressing it down by a factor of 2. So it makes sense that if pi over 2 and 3 pi over 2 were our solutions when our angle is just x, when it's now 2x, it should make sense that it's pi over 4 and 3 pi over 4. All right, just thought I'd cover that in case you run into that. All right, let's go to the next one. 3 cosine squared of x minus 5 cosine of x minus 4 equals 0. So here, and again, I mentioned this in the last video, a lot of these equations should remind you of simpler equations that we've solved in the past. And this reminds me of a quadratic, a trinomial. It has 3 parts. There's a squared, there's a first power, and then just that constant. And one of the techniques that I use sometimes to clear it up is I just do a simple substitution and I say, well, what if u was the cosine of x? Then this would just be 3u squared minus 5u minus 4 equals 0. Replacing the cosine with a u, and then it's very easy to see that this is a quadratic, and then we know how to solve a quadratic. We could attempt to factor this one. This one does not factor, so if it doesn't factor, we go to the quadratic formula. And we say, all right, well, quadratic formula, u equals negative b, so that would be 5 plus or minus the square root of b squared minus 4 ac all over 2a. There we go. There's our quadratic formula. So we get u equals 5 plus or minus the square root. Well, that's 25. That's 16. 16 times 3 is 48. So we have 25 plus 48. 25 plus 40, 65 plus 8 more, 73 over 2. Oh, not 2. 6. Whoa. There we go. Okay, so have we solved the equation? No, we solved for what u is equal to. And recall here that u is the cosine of x. That's what we just replaced the cosine with x with was u, so it looked more like a quadratic. So really this tells us two different things. It tells us the cosine of x equals 5 plus the square root of 73 over 6, or the cosine of x equals 5 minus root 73 over 6. All right. So then, now how do I solve this? Where is the cosine equal to 5 plus root 73 over 6? I have no idea. That's not on my unit circle. However, I will recall that we know what inverse trig functions are. If the cosine of x equals this, then x equals the arc cosine of that. Okay, that's how we define our trig function, inverse trig functions to be. So then I'm going to put this in my calculator because I'm curious on what this angle is. Now I think it's usually a little bit easier to do this with angles in degrees instead of radians, because our brains work a little bit better with those because we're a bit more familiar. So what I'm going to do is I'm going to make sure my mode is in degrees, which it is, so that's good. So I'm going to type in the arc cosine. Now remember, arc cosine is not a button on your calculator when it looks like this. Remember, another way to write arc cosine is the inverse cosine with that little -1 up there, that inverse notation. So I'm going to take the inverse cosine, make sure you have parentheses around the numerator, 5 plus the square root of 73 over 6. Error. Did I type it in wrong? Inverse cosine of 5 plus root 73 over 6. No, it looks good. Why am I getting this error message? Well, the error on my calculator actually says domain. If I just type in 5 plus root 73 over 6, I get about 2.26. This is about 2.26. Okay. Can the cosine of x equal 2.26? No, what's the range? The range of cosine is -1 to 1. Okay. The domain of arc cosine, okay, is -1 to 1. We can't ever have the cosine equal to this number. Okay. That's not going to provide us any solutions. Okay. So how about this one? Well, I'm going to learn my lesson here from the other one. I'm going to type in 5 minus the square root of 73 over 6 first, just to make sure it works. I'm going to get about -0.59. And can the cosine equal about -5.59? Yes, it can. So I am going to take the arc cosine of 5 minus root 73 over 6. And when I type this in my calculator, I get about 126.2. Now remember, I put that in degrees. So there we go. There's our solution. Correct? Well, how can we check our answer? Let's go to Desmos. Y equals 3. I'm going to put cosine of x in parentheses there to make sure it's all squared. 3 cosine squared minus 5 cosine minus 4. And I think it's probably going to want parentheses around that angle so it knows the -4 is not inside the cosine. There we go. Now we wanted to know where was this equal to 0. And we get that number. Okay, well, right now I think we're in radians. Yep, down here at the bottom. Let's switch to degrees. It looks like the graph moved. However, we're now talking about degrees. We're used to look at like 0 to 2 pi, about 6.28. That was our radians. Well, now we have to go 0 to 360 degrees. So let's change our window here. And let's make our window from 0 to 360 degrees. There we go. So it looks just like it before, but now this is in degrees here. Kind of a cool looking graph if I zoom out a little bit. So where does this equal to 0? Right there, 126.2 degrees. We came up with that. But is there another place in our first revolution, 0 to 360 degrees, where it's also equal to 0? Yes, right there. Where is that answer coming from? Well, we have to remember that we restricted the range of arc cosine, so it's a function. Okay, when we type it in our calculator, and we talked about this before, it's only going to give us one answer because our calculator has it as a function. However, we're not looking at this as the arc cosine function. We're trying to solve an equation here with trying to find all of the solutions. So we have to ask ourselves, if the cosine of 126.2 degrees gives us 5 minus root 73 over 6, what other angle would? So let's picture our unit circle. There we go. Now, where's 126.2 degrees? That's going to be somewhere in the third quadrant, maybe around here. $126.2, that was the angle, right? Yep. So at this spot, our cosine is equal to 5 minus root 73 over 6. And remember, cosine is the x value. We don't really care what this y value is. Okay? What other angle will give the same value for the cosine? Well, our cosine is x values. So if I draw a vertical line to find where else do we have that same x value, that same x value also shows up on our unit circle right here at this angle. So how do we find that angle? What is that angle? And this is going to go way back to when we started our trig stuff, using things like reference angles to figure out what angle this is. All right, so how are we going to do that? Okay, I know some students tend to think like, oh, let's just add 90 degrees. No, we don't know that that's 90 degrees. Here's what we know. We know this is 126.2 degrees. Okay. Do we know what the reference angle right here is? Well, if I take 180 minus 126.2, we get 53.8. So this angle right there is 53.8. Now, with the symmetry here, this angle right there is 53.8 degrees also. So this angle from there all the way to there will be 180 plus 53.8, which is 200. Where should I write this? I'll just write this. Well, let's take 180 plus 53.8 equals 233.8 degrees. Okay, so that is our second solution, and let's see if that's what it is on Desmos. There it is, 233.8. So you need to recall, you need to remember, this is an important one. When you type in arc cosine, arc sine, arc tangent on your calculator, you're only going to get one angle. You have to ask yourself, is there another angle? And you've got to do a little sketch here to figure out what that other angle is. You can do it. Okay? Don't be scared of it. Just draw it out. Remember that cosine are x values. Now, if this was a sine problem, I would have had to draw a horizontal line to find the other point where the y value is the same. Okay, so just be careful with that. Now, tangents, okay, we have to actually look across quadrants, if we were still in this quadrant, from quadrant 2 to quadrant 4, because that's where they have their, like, so tangent goes positive, negative, positive, negative. So these two quadrants match up and those two quadrants match up. So just be aware of that. Looking at my time, I'm going to wrap this video up. We have a couple more examples to look at. Thanks for watching.